I do have a few announcements. So you have things due Friday. You have your Unit 2 notes Friday. You have syllabus statements due Friday. Unit 3 notes should be done Friday. You have things that you should be working on. Sure, it's also posted on Google Classroom, but you can always take a picture. All of this is to prepare you. Guys, whatever you're doing, it should be silent. All of this is to prepare you for your test, which we have to do Monday. So, for everything that's due on Friday, I will actually be collecting it Monday. That doesn't mean you should wait until Monday to finish it, because if you don't finish your notes until after the test, then that's not as helpful, right? So really try to get everything done by Friday so you have Saturday and Sunday to study rather than to be looking at the information for the first time. We're going to continue a little bit of time. If you need a little more time on a microscope today, you can have that. If you're good with your drawing, if you have a picture, you're good to go. Tomorrow, I will be absent. Actually, both of us will be absent. We're going to be at the district office doing a training for IB, actually. So what I have for you to help you further prepare for the test, I have a Nearpod. It'll be a review Nearpod. So it'll be posted on Google Classroom. It is something you can go through self-paced. Okay. It will be graded. So I will be looking to see that you completed it. Okay, I can go into my reports. I can see that you did the Nearpod or not. I don't think the Nearpod will take you the whole class period. So finish the Nearpod, use it as review, then finish or study your notes. At this point, you guys can work together. If your partner has page 7 filled out and you don't, you can work together. I'll make sure to tell the sub that there's some group work that you guys can do, okay? Does not mean that you guys are crazy, loud, rowdy. This is tomorrow. This sub, I think it's her first time subbing here. So I don't think you know this stuff. I don't know this stuff. I've heard that she's good though. Guys, so you have a list here. Finish study your notes, finish study your syllabus statements. Basically, get on Google Classroom and make sure you've got everything squared away. Because remember, you have 2 sets of notes due Friday, 2 sets of syllabus statements due Friday. All of these you should have been working on, so you just need to finish it up. Okay? In terms of behavior for the sub, I like to say I don't feel too concerned, but something that is starting to happen in here is we're getting in here a little bit later, and we're not like sitting down starting right away. I've noticed it's like come in, talk to each other for a second, like hang out for a second. We need to like come in here, get started right away. Okay, so tomorrow I need you guys to make sure you do that. Get in, get seated. Be very respectful to the sub. We have asked the sub to give us detailed information on behavior. I want to know everything that happens. And if we have concerns, I will deal with it. It will not be a fighting conversation.
If you want to remind you guys, just if the sub is here, she'll be taking attendance to seating chart. I know some of you are a little bit cool and we're okay with that, but for tomorrow, just make sure you're at the seat that's on the seat chart.
Yes, ma'am.
Yes, very important. And whatever the sub asks, even if one of the things I really hate when people do with subs are like, well, my teacher doesn't make us do that. I hate that. It doesn't matter. The sub is your teacher that day. So she asks you to move. She asks you to do something. It doesn't matter what I usually do. Okay? Just be respectful and do what the sub says. Okay? We all good about tomorrow?
Yeah.
Cool. So in terms of your homework, I know there's been a lot of self-guided work for this unit, but this might happen sometimes, okay? Like I said, we have a pacing schedule. We have to stay on it. So I just want to go through a few things your homework to just make sure that we are all good and you don't have any questions. So page 4, which was one of your homework pages last night. I hope you got my reminds. I sent you 2. Sent you one like during school and one later in the evening. Okay?
I saw those.
Yours? So we have to, if you're not getting them, we got to figure out why. You still maybe turn your ringer on or your alerts on. Yeah, so maybe that's the problem. So in that's the case, you could do what I do. I have myself an alarm set on my phone for 6:30, and it says send reminds. So that tells me to remember to send you a reminder. So what you could do if you don't like your ringer on, you could set an alarm for 6:30 and say check my phone or check my homework. That way you can remind yourself to look at your reminder. You did? Okay. Yeah, I usually get like little alerts on my phone. So, okay, so for your drawing, this really should be done because you've been given the answers, right? If you were drawing yesterday, I said try to draw it on your own and then check your answers. So based on last night's homework, using this slide, your drawing should look similar to this. I do appreciate a lot of you guys were doing the stippling shading, which actually was better than this drawing. So good job on that. If you don't have your drawing finished, you want to look at this slide, make sure your title is there, your labels are there, and your scale bar is there. Okay? If you're not done with that yet, we need to be done with that. At the bottom of that page, you are supposed to compare or to look at the difference between the nucleoid and the plasmid. So in bacteria, in prokaryotes, I will say, one of the differences is their DNA. In prokaryotes, we have circular DNA that's naked, and eukaryotes is different, right? We'll go more into that later. But even in the prokaryotic DNA, there's 2 sections. Okay, so this is what you were supposed to fill out at the bottom of page 4. Okay, so I understand there's like some people on microscopes, some people writing here, it's already there. The point of what I'm doing right now is to make sure you don't have questions. So if you don't have questions, whatever you are doing right now is okay. But try to have an ear open, right? So the nucleoid region, that's your main DNA. It is one single loop. It is naked. You should know what naked means based on your notes. But naked means there's no proteins. Okay, eukaryotic DNA is not naked. Prokaryotic DNA is naked. So basically, there's no proteins that the DNA is wrapped around. Yeah. Now I'm going to take your drawings from your microscope and your drawing in your packet and assume that you have gotten that stuff. Yes. I might have a question or 2 on the rules of drawing, but you won't be asking. Okay, so the nucleoid region, as we can see in this image, is your big main section of DNA. And then we have the plasmid. Notice how the plasmids are much smaller in this image. Okay, plasmids are extra pieces of DNA. So with our prokaryotes, they're actually some of the most important pieces for us because we use them all the time, especially in biotechnology. So the plasmids are very useful for us when we try to do biotechnology applications. They are still circular and naked, okay? They're smaller. They replicate independently of the nucleoid DNA, so they're completely separate. You don't find them in all the prokaryotic cells, but they are very interesting to us, okay? Actually, in one of our later units, we'll talk about plasmids and how we use that for genetic engineering. Okay, naked, you should know this. It means that the DNA is not associated with proteins. Just naked. just DNA. If you look at eukaryotic DNA, it's wrapped around these little orange proteins. We'll talk more about that when we get into eukaryotic cells. But for now, just know naked means no proteins, nothing associated with it. All right, this was something you did the other night for homework. Just know the difference, the main differences between prokaryotic DNA and eukaryotic DNA. Okay, so that's just a table. There's not really much I can do to help you study that. You just got to study that. Let's do a couple of these examples. I'm going to use my cards. This is something that you should have gone through on your own, but you didn't actually have to write down the answers. So I want to just make sure we know. All right, I'm going to do a shuffle. Alexis, would you say this is prokaryotic or eukaryotic? Couldn't hear the beginning. Pro or you? Pro. Pro. This one is prokaryotic. Can you tell me, Malia, a reason why? It is circular. That is one main thing. Prokaryotic DNA, if we stretch it out, would make a circle. Okay? One continuous piece that is joined at the end. If you look at it in your drawings, right, it's kind of all clumped together. But if we were to stretch it out, it would make a circle or an ellipse. But it's joined together at one end. There's another reason. What does it not have, David, associated with it? Naked, meaning it does not have what? Histone proteins. There's no proteins. It's just the DNA, right? Just the spiral DNA. This would be a great thing for you guys to make sure you know, because likely to be a question on the test.
But is pro always going to be circle?
It will. Sometimes it looks like this, right? Because it's all clumped together. But if we were to stretch it out, it would make a circle or a circular-ish shape. Doesn't have to be an exact circle. All right. Looking at this picture, prokaryotic or eukaryotic? Eukaryotic, very good. How do we know this? Malia, again. What's the reason? It does. We can't really see them in this picture though, but it would. Also, it is many pieces that are linear, right? Prokaryotic DNA, other than the plasmids, is one long big circle. Eukaryotic DNA, we have 23 different types, 23 different or 46 different pieces, really. Okay, that was a bad picture. This one, prokaryotic or eukaryotic? Ricardo.
Yes.
Prokaryotic. So this is a really good example. It's not a circle, perfect, right? But it is circular. Okay, it is circular in the way that it is connected at the two ends. So prokaryotic DNA might be wiggly in weird shapes, but it's connected at the beginning and the end is connected. Eukaryotic DNA is just one strand, actually 46 strands, but they're not connected at the end. So that's what we mean by circular, okay? Doesn't have to be a perfect circle. All right. We can't really see in this picture, but it would also be naked, does not have proteins. All right. Okay, this is another picture of prokaryotic. See, it's not a circle, but you can see that it's all one piece that's connected at the end. Yeah. This one, you can see this is going to be our eukaryotic DNA because it does have those proteins. Okay, so notice that our double helix is wrapping around these proteins. So this would be not naked because it's wrapped around proteins. Okay. The next section in your notes was binary fission. This was page 6. So we need to know the process of prokaryotes dividing. We talked before about sexual and asexual reproduction a bit. So we want to know that prokaryotes do asexual reproduction, which you should have written down. And specifically a type of that, which is binary fission. You guys watch this video? It's very quick. We can watch it.
Bacteria reproduce very simply and rapidly by doubling their contents and splitting in two. Just one bacterium, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in one day.
Billion.
Bacteria
Okay. So you should know that asexual reproduction is a single parent, right? There is not a collection of genetic material. It's just one parent making a spawn. So the spawn or the offspring is genetically identical. Okay, so make sure you know what asexual reproduction means. And binary fission, specifically your second definition, is how prokaryotes do asexual reproduction. There's different types of asexual reproduction. But for prokaryotes, it's binary fission. So this is when a prokaryotic cell is divided into two parts. That's basically just the simple definition. So binary is BI is what? BI is the root word for what number? 2. And fission means to pull apart. We may know the word fusion, right? A lot of people know the word fusion. Fusion means what? To combine, put together. I know in the culinary arts world, like fusion is really big right now. Like we might take Chinese, Mexican fusion. Like that's a thing. That's a thing. When I watch my cooking shows, they always are like, "Ooh, this is a fusion dish." It's like a Vietnamese, breakfast, Mexican, something. Anyway, fusion means we're putting together, right? Fission is the opposite. Fission is the opposite of fusion. So fission is pulling apart. It is. Look it up. There's all of these.
No, he asked me about a different.
Also, fusion is what happens in the sun when you have atoms fusing together to make elements and create energy. All right. This video you should watch. It'll go through binary fission.
Most bacteria reproduce
There you
by a
go.
process called binary fission. During binary fission, the parental cell divides to form two daughter cells. In the first step of binary fission, the bacterium replicates or copies its chromosome and attaches each identical copy to a separate location on the cell membrane. Unlike eukaryotic cells, bacteria do not need to dissolve a nuclear membrane or assemble a mitotic spindle, making binary fission.
So basically, the short part, it duplicates its DNA, right? It still has to do DNA replication, and then the cell kind of grows and divides. It's a very simple process. So these steps you should have written in your notes. So if we didn't do our homework last night, right now, you could be possibly getting a better education if you weren't copying something other than what I'm talking about, right? But you got to learn that skill. So first thing that happens, it prepares by getting enough energy and resources to divide. DNA replication is the second step. Try to make it simple. Then the DNA attachment. We have to make sure that half the DNA ends up on each side, right? So the DNA will actually attach to different parts of the cell so that when it separates, one piece actually goes one way and the other goes the other way. We also get more cell growth because it has to get bigger, right? If you're going to make two organisms, you have to grow first. Then pinching in is very similar to cytokinesis. You just get a pinching in, creating the furrows, and then eventually those furrows will be a division. So it's very simple process, but you do need to know the steps. So yes, those furrows eventually will separate, and then we get our two identical daughter cells. I don't know. Because we're sexist in here. Because somebody decided a long time ago.
So missing.
The next section, I'm actually going to, this was homework as well. So I gave you a few resources and you just need to answer these questions, okay? What are antibiotics? How do they work? Okay, we should know that they are a medicine that kills bacteria. Antibiotics, like bacteria, okay, maybe is what you could think of. We should know that they don't work against viruses. I actually have some notes that we'll do together on that. Who discovered antibiotics? Who did the homework? What's his name? Thank you.
Oh, I learned that about
Yes, Alexander Fleming should be the answer, and you want to summarize his story with his, what did he develop? Mold, which turned into penicillin. Yes. Why are they important? Because
It help your body.
they help you not die. I would say they save lives. Because people used to die from things that we don't die from now. Yes, helps protect from death. Yes. Okay, here is the video that will help you answer those questions. And another video about Alexander Fleming. Yep. Maybe he was when he was younger. And you have an article you can read as well. If you didn't get all the answers from the first two resources, you can read this article, give you all the answers. This is where we are going to start our notes together. I'm going to give you a couple of minutes. I need to come around and check in on how we're doing with drawings and what you guys need in terms of support on that. And then we'll get started. Okay. So do you guys have page 4 drawing done? Well, you need to measure. You need a ruler. Yeah. Well, see how they did like the length of it. But you're gonna need a ruler to measure and then do the calculation in the bottom left corner. So grab a ruler.
So
Not for me, mine are gold.
yeah, so I had film yesterday in my room 30 something, and I saw them on table. I started playing with it, and then I like walked out not knowing I was playing with it, and then like I realized that
Your labels have to be horizontal. Not be vertical. Notice those labels, how they're straight and horizontal. Grab a pencil. Okay. So we all need our scale mark.
the other pencil.
Oh, so you need to change that. You gotta do the bottom left calculation. So just erase the one thing. Right, you're gonna need a ruler to do it.
That's legit.
How many millimeters is that line?
That is drawing the brush.
153. Okay, so you're gonna do 78,000 equals 153 over x in the bottom left corner.
Yeah.
Do that same calculation, but with 153 instead. And And then the answer that you get, you'll write on. Okay. Here's it. What's yours, 150? Exactly. We're gonna do that too. You're gonna do 156. So do that bottom left calculation, but with 150.
Wait, what are we doing for English today?
For our title, remember we need it to be as seen
Why didn't you pick IB math?
under microscope. Under magazine.
It's the same thing.
The subject of this one. So as make that title look like you said. And actually only the equal like.
But calculus and
If you're doing
statistics are
curve,
calculus.
we also want the zero.
Calculus is hard.
Also,
Something you're gonna have to take in college anyway. No, but if you have general ed, you probably would.
Regardless, I trust train to.
When you're Indian, you go to Kumar.
You can't make those jokes when you're Asian.
Oh, dude, I just want If you rob an old lady, it depends on how much money she got. Well, I mean, if she has like 50 bucks, I'll be like, okay, I'll beat you up only.
If she's like,
I'll beat her up.
it might only take a little bit of me.
Like if she's filthy rich.
Like, you have money.
Oh.
I think I'd probably just trick her and say that she gave me all her money.
Oh, but old ladies. Oh,
No, just I can just convince her of her son.
yeah. Son.
Well, hated it.
Oh. I remember that song. Oh my god, that song was so catchy. And then like he came out with like the ones like, hey. And then he just fell off. She said she took me long. What are we doing? Get your scales on. There you go. I smile with a little eyes, but really not you. Sam, do you think we could be committed to one person? That's hard. It depends. If they're boring, then it's like hard. You guys just start cocaine together.
Remember in middle school, we used to have sperm wars.
Never had that.
Wait, we never did?
When did we ever have
Yeah, I'm just joking. You never had that?
that?
No.
All right, we are moving on in 1 or 2 minutes. If you have questions, now's the time to ask. It will be pretty hard for us to get our scale bar in there.
Join the high school Christian club.
You're gonna want to look up mosquito.
Hello, everyone. I like that you got it like.
At least have eyes.
Oh.
So I would try to find an image online that looks this and label it. Also, this. Yeah. Only the. Okay.
I know they had an art lesson. Oh, I saw.
Doing good. Doing good. Yes.
So I would just divide.
Is this exactly 150? So that should be 150.
Over what?
X. It's all for X. Are we doing?
Yeah.
Almost done?
Yeah.
Late? Did you get my remind?
Yeah, but like.
It did because I left my phone in the car. Gym.
I knew Mr. Lizzie would. I
Yeah.
knew it.
Yes. Pretty much
Why is
every
he
day.
so hot?
Pretty much. He was so mad because he was like buffer and then quarantine hit. And he wasn't motivated enough to keep working out at home. I was like, just do some push-ups. He's like, well, I'm not motivated. So he lost all his games and then now he can go back to the gym, so we have to get him all back.
I remember during PE last year, someone challenged him to like a contest thing. Like,
With a snake on. Yeah, that's the thing. He needs to be around other like buff guys working out to like have the adrenaline. to, like,
Yeah,
work
me too.
out.
I need to be around like hot, like juice heads.
And then he goes home, he's like, everyone at the gym is so much bigger than me. Like that's because they kept working out over quarantine.
If he works out with Mauricio.
He's also not very tall. I'm like, you're never gonna be like that big old big buff guy.
He just needs to eat a lot.
But then he would look. I feel like it looks weird when they're super short and then.
I need to
What?
That's old.
This is just my personal preference. I'm saying those people are bad or ugly.
What if
Do you
what if
think
he
all
can't-
women are attractive?
Heck
single one of
no.
Alrighty. We are going to move forward in our notes. So whatever you're doing, I do need to ask you to pause. And please go to page 8. Page 8. Everyone is pausing what you're doing. If your Chromebook's open, that is only because you are on the slides on the same page as me. Okay, so we are no longer doing last night's homework. We are pausing our drawings or stopping all of that. Okay. Thank you, Sammy, for being on the correct page. Thank you, Tanya Table, for being on the right page. Page 8. You should see some mic.
Why is that?
All right. We have 4 Chromebooks open. I don't know why you guys need them open. You can see the screen just fine. If that's what you're doing, that's fine. I just want to make sure we're not doing last night's homework because you can do that later. Okay, what scientists are we about to learn about? Nope. Yes. Very good. Okay. So this is an application standard. Look, A3. So we're applying our understanding of antibiotics to a real life case. I'm seeing Chromebooks not on the same slide as me. So at this point, we're all together. All together. Where did penicillin come from? Well, we know it came from who's that original scientist? Alexander Fleming. But Howard Walter Florey and Ernst Boris Chain were the scientists who followed up most successfully on Alexander Fleming's discovery of penicillin, sharing with him the 1945 Nobel Prize in Physiology or Medicine. So here is just, you don't have to necessarily read this, but look, it's like news from Florey and Chain are on here. Not important. Penicillin as a chemotherapeutic agent. So Florey and Chain studied the biochemical and biological properties of selected antibacterial substances produced by certain microorganisms. So they didn't only study penicillin, but that was part of their main discovery. So here was their experiment. You're going to annotate your image of mice. Might be good to have colors. Basically, if you want to get a box in the back, you can get red and green. Or maybe circle one and don't circle the other. Or I think you'll be fine either way. So what you want to show is that there were two groups of mice. In one group of mice, they gave an infectious bacteria plus penicillin. The other group of mice, sadly, did not get the penicillin. But they did get the infectious bacteria. So they were purposefully injected with bacteria that was designed to kill them. So they wanted to see, is penicillin going to save these mice? Did it? Yes. The antibiotics were able to kill the infection. So I want you writing your arrows, your 3 arrows with labels, and also the little top bubble. Generally anything in red, right? Are we used to this pattern yet? Okay. So the antibiotics kill the infection, and what you should have learned from your antibiotics video last night is that they work by blocking processes that occur only in prokaryotic cells. Yes. Just point at the mice. It is your arrows, as long as they go to that mouse. So the reason why antibiotics don't kill you is because you are made of eukaryotic cells. The antibiotics are designed only to block processes in prokaryotic cells. Then it would kill you. If you were a prokaryote, an antibiotic would kill you. It gets a little tricky because we do have prokaryotes that are called superbugs because they evolve, and now our antibiotics don't work. So there's a little more to that story, but in general, antibiotics kill only prokaryotic cells, which is good. Can anyone think of maybe a problem with that? And if you've ever been prescribed antibiotics, you may have heard of it. Sometimes they don't always work, and that's because if you have taken this antibiotic many times, your body could build immunity, or whatever you're infected with could have evolved past the antibiotic working. Yes. Okay. Kind of like, I don't know if you guys have heard this, but there's the new COVID after Delta.
What?
There's a new one. New? Is it new? Yeah. So there's a new one, and they're saying, this is very important. They're saying that it's fungal, which is good, but it is way more resistant against our vaccine. So our vaccine may not work or may not work as good. So, guys, have the same thing with antibiotics. The other thing we want to think about is, are you 100% eukaryotic cells?
No.
What do you have living in you? Prokaryotes, specifically in your gut and other places. You have good bacteria, right? So we could get into some problems with our antibiotics killing our gut bacteria. Generally, you don't have to take them long enough, right? This is why you don't take antibiotics every day. Take them for a couple weeks, kill the bacteria, and stop, right? Okay. By the way, experiments done by Florian Chain would not be compliant with current protocol. That's part of our notes. We're going to look at how testing in the past didn't follow all the rules. And what are the rules we have now? Okay, so Florian Chain followed up the mice experiments with additional testing on more mice and in 6 humans. So under the mice, we are asked to summarize. We're going to summarize the story that we are about to hear. You can read it, but we're going to listen to it. The tragedy and triumph of the first human trials of penicillin. So, like I said, you can read it, or where's my thing that we can listen to it? Man, ads are just getting worse and worse, aren't they? I thought we could listen to this one. I thought at the top there was like a listen to this. Nope, I guess this one. I guess I'm wrong. Okay. In early 1941, a 50-year-old woman whose name is lost to history was dying of metastatic breast cancer in an Oxford hospital ward when a doctor approached her with an odd request. He was testing an injected drug called penicillin, which he and his colleagues believed would save countless lives by killing the bacteria that caused common infections. They had tested the drug on mice, but they didn't know for sure if it was safe for humans. She had very little time left to live anyway. Would she help them test the drug? She agreed. Now, just checking in. Is this drug going to work on what's killing her? No, because cancer is not a bacteria. So they did not say this is going to cure you. They basically are checking, well, you're dying anyways, so can we check and see if this drug negatively affects you? Okay. Would this be allowed today? No. Even if the person agreed, has passed our rules. At nearby Oxford University, Ernst Chain and Howard Florey had been working out how to purify penicillin since 1939. They did their mice experiment and watched the drug fend off streptococci infection. So you put bacterial infection, specifically the name of bacteria was streptococci. Their work looked promising, but they could only justify human testing on a terminal patient, someone so sick they had nothing to lose by taking an untested drug. Dr. Charles Fletcher later recalled that when he injected the first dose of penicillin on January 17th, the patient at once said that she had a curious musty taste in her mouth, but suffered no other immediate harm. A blood sample taken shortly afterwards was bactericidal, okay? Meaning that in her blood, she had antibiotics, and maybe that blood could have even killed bacteria because it had antibiotics running through it. A few hours later, however, she developed a rigor, and her temperature rose for a few hours, but there were no other ill effects. Rigor is like being stiff, right? Rigor mortis, you've heard of? Rigor is just kind of being stiff. The team tested injections on a few other terminally ill volunteers over the next few weeks. It became clear that the penicillin was safe, but would it work in humans as well as it had in mice? So you have your first human test. We just talked about it. Put that in a couple sentences. They injected the penicillin on terminally ill patients. We don't know her name. We know she had cancer. I would say terminally ill, like non-bacterial symptoms or something like that. To know that they knew they weren't going to cure these people. Terminally means they're going to die, right? So they tested on terminally ill patients and found what? What did they find? It was safe. There was no serious negative effects. Yeah, but even a fever, if I'm going to take this drug and it gives me a fever, but it saves my life, they would still say that's it. Terminally ill patients, volunteers, you might want to put volunteers, they were volunteers. And they found that there were no or very few negative effects. That fever that she got could have been from her cancer too. So it wasn't a super controlled experiment because we weren't testing it on a healthy human being. That really would have been unacceptable, right? Even if they volunteer, we still have rules against that. Because people can say they volunteer, but were they manipulated? Were they pressured? Are they doing it for money when we shouldn't be putting them in that position? Okay. Well, I think with the vaccines, they probably started on mice and things like that. And then generally what we do is we test it on mice, and if it's safe on mice, which are mammals like us, then sometimes they'll go up to like chimps, which is even closer to us. Then they take human volunteers, but they have to go through these steps first. Okay. In December 1940, a 43-year-old constable, this you don't have to add this, but we'll just talk about him for a second. He was part of the Oxford County Police force, scratched the side of his mouth while pruning his rose bushes. That sounds like the kind of injury you just laugh off, especially if you're a police officer in wartime Britain. But in the days before antibiotics, a small scratch could kill, eventually. Infection set in, and Constable Alexander found himself facing blood poisoning and painful abscesses. He lost an eye that winter, and other abscesses threatened his lungs. He was dying and doing it painfully from a scratch on his face. That doesn't happen anymore, at least not in America. With, in Fletcher's words, all to gain for him in a trial of penicillin and nothing to lose, Alexander agreed to the test. So now we're stepping it up. Now we're finding a human who is on his way to death, but it's caused by a bacteria. He is not a cancer patient. This is caused by a bacteria from the rosebush. Alexander agreed to the test. He received his first 200 milligram injection of penicillin on February 12th. He started getting better within a day. His fever dropped, appetite came back, and the infected wound and painful abscesses began to heal. Over the next 4 days, daily penicillin injections brought steady improvement. For the first time since December, things were looking up for Constable Alexander. Then the penicillin ran out. It had taken Chain and Flory months of work in their lab to produce and refine enough of the drug to treat the human patient. Wartime supplies were tightly restricted. Doctors tried everything they could, even extracting penicillin from his urine in an attempt to stretch the supply. But by February 17th, they had run completely out. Didn't take long, the infection returned. He ended up dying later on. How frustrating. They're like, it's working, it's working, it's working. And now we're out and there's nothing we can do about it. Yeah, they couldn't, like I said, the restrictions, the wartime restrictions were tight. They couldn't make any more. So poor Constable died anyways, but he did help. Right. Yeah. But how frustrating. It's like, oh, I'm gonna live, I'm gonna live. And then, so here's the constable. There he is. Hello. This is just telling you the same thing. Oh, that's the thing we could have listened to. It's the same story though, so we're gonna skip it. We don't have time to do this. I'm sorry. Basically, this was other examples in history where people were doing unethical experimentation. You guys know they were doing crazy experiments. Crazy. I tried to look at it. You can make this. In your packet. Page 9.
When did they make the first hill? Like, it's-
So this is basically password present. Right?
I guess it goes up. I just get some medicine and put myself on it.
And looking at our time, we are gonna have to do the rest for our homework. It's really like I keep saying, I hate to do this to you, but we have a schedule we have to keep on. It took us a little longer to do microscopes than I thought it would. Yes, possibly because we didn't have enough to start, so that will be different next year. Well, we already have more that we borrowed from the lab that we did when we tried from the chem lab. I do possibly plan to buy more. They're about $400 each. I buy a couple each. So the next things that you'll go over, the Nuremberg Code. The Nuremberg Code actually came out of World War II because of the Nazi testing. A lot of the scientists, we could call them scientists, I guess they were, they actually got prosecuted for doing what they did to those human beings at the time. After the war was over, there was a collection of people who decided that was not okay, we need to prosecute them. I don't remember exactly what happened to them, but I know that people were trying to bring justice to what happened. Okay. So from that, the Nuremberg Code was created. So what you'll do is there's a link. Okay, there's a link in the presentation. You're going to go to it. You can read about what is the Nuremberg Code, which is basically our set of rules that we have today. And what are those rules? There's 10 of them. So you literally can just list them down. And when you look at them, you're probably going to be like, yep, that's a good idea. Like, these rules are good to have. Keep humans safe and keep us doing the right thing, right? I know the people who did the presentation on the Nazi testing, they were saying what they were doing to those people wasn't really necessary. A lot of those things we didn't really need to know to make the world a better place. There's a lot of things we could do in science, but should we? Okay, so we need this Nuremberg Code to keep us on track. Because, you know, human beings can be a little crazy sometimes. Yep. So basically, you guys know your test is Monday, okay? So your job is to finish the packet by before then, so you can study it. You have your syllabus statements, okay? You have all day in class tomorrow. You're going to do the review, which will help you review what should be in your packet. Would it be smart to come into the review with an incomplete packet? Probably not, because then you're just going to struggle through the review. I did tell the staff if they need to consult their notes to help them on the review, that makes sense. It's not a test yet, right? So it's not going to help if your notes aren't done. So I will send you another remind, hopefully at 6:30 tonight, if I don't leave my phone in the car. It's 6:30. 6:30. I consulted all of my classes and 6:30 was the best average for everyone. But you can always write down in a planner your homework. Technically, you should not be relying on my reminders. Right? I did not have a teacher sending me reminders when I was in high school. I wrote down my homework and I remembered to do it by myself. So that's the goal, right? You probably will not have college professors sending you reminders to do your homework. So maybe am I hurting you for the future by helping you out this way? Maybe set yourself a goal to remember to do your homework before 6:30. And then when you get my reminder, you're like, oh, I already did that. But thanks for the reminder. That would probably be the goal. Okay, so any questions about tomorrow?
No, ma'am.
Okay. On Monday, you guys are gonna take your test. Okay. I do plan to collect your drawings, your blank paper drawings. So try to get those done to the best of your ability by then. That grade is gonna be part of your notes grade. Okay, so if you turn in perfect notes but no drawing, you will not have perfect notes grade. Okay. Also, yeah, I guess that's it. You guys know what to do. Your notes, your syllabus statements. I will be posting an answer key to the end of your Unit 2 packet tonight. And be good for the sub tomorrow. Be your most respectful self. And of course, let me know if you have questions or need help on anything. Thank you, you too. Have a wonderful day.